Our next thing that we need to learn about when we look at covalent bonding is atoms that share more than just one pair of electrons. And these atoms have multiple bonds. And we can have either double or triple bonds. So these types of bonds are double or triple bonds. Now, how do you know to use a double or a triple bond? Well, you're going to follow the same procedure that we did for the single bonds, but you're going to find that you're left with atoms that don't have a full valence. When you don't have a full valence, then you know that you need to do either a double or a triple bond. We're going to follow through the same process that we did for single bonds. We're going to draw each atom individually, and we're going to draw its electron dot diagram. And as promised, I'm not going to do them in different colors today, right now. What we're going to do is we're going to just use one color, because it really doesn't matter where the electron, that you clearly indicate where the electron is coming from, just that they're being shared. So same process. Our central atom is going to be the atom that has the greatest number of bonding electrons. By the way, that's also called the bonding capacity if you happen to be reading in your textbook. So my atom that's going to go in the middle here is going to be carbon. Okay, and one of the things you'll realize as we do a lot of these is that if you've got carbon, it's going to be the central atom. So I'm going to do its electron dot diagram. There it is. And now what I'm going to do is I'm going to basically put in the other atoms, my oxygen, 1, 2, 3, 4, 5, and it's sharing one electron with the carbon. Now, take a look at my carbon. You guys see when you count electrons around it that it's got 7, not 8? So that one doesn't have a full valence. Let's also take a look at oxygen. Count the electrons around that one. Do you guys see that it also has 7 and not 8 valence electrons? So now this is where we're going to have a double bond. And so what happens here is you've got two sets of electrons that are shared. So this one basically shares this other bonding electron and this bonding electron, and they basically go here. Okay, so you actually have a double bond. Now, please do not leave those arrows when you go to hand in assignments or do assignments. I'm just doing this as part of the notes. What you would do is you would redraw this. I'm going to do that here. All right, so that's what this would look like. So again, take a look at the carbon and just look at the electrons around the carbon. Ignore the atoms. How many electrons does the carbon have? Well, 1, 2, 3, 4 with the hydrogens, but now it's sharing basically 4 electrons with the oxygen for a total of 8. Same thing happens here with the oxygens. Just count the electrons. And you can see that oxygen now also has 8 as well. So both of these atoms now have a full valence. Instead of just sharing one pair of electrons, they're sharing 2 pairs of electrons. Now the last thing that I need to do before we do our next example is, what does the structural diagram look like? Remember, structural diagrams, we use a dash to represent a bond as opposed to the dots. So for this one, the hydrogen is going to be very straightforward. It's just the carbon with the hydrogen, because that's basically a single bond. But with the oxygen, because I'm sharing more than one pair, each pair is represented with a dashed line, and so I have a double bond. So that's the structural diagram for basically HCHO. All right. We're going to do O2 next. We're going to work our way down and across today. So with oxygen, again, it's got 6 valence electrons and it's bonded to itself. So here's oxygen with its 6 valence electrons. It's going to bond with another oxygen with 6 valence electrons. And at the beginning, you can see that each oxygen has only 7 electrons around it. It shares, again, a second pair. So for this one, the structural diagram is oxygen with a double bond. And again, the structural diagram, O double bond O. We're going to repeat this then with nitrogen, and again nitrogen with itself. So there's one nitrogen with its 3 bonding electrons. One of them is going to bond to begin with the other nitrogen. Now you can see that this one is really not full at all. So what we're going to do is we are going to share one pair there. You guys see that we're still not full? So we're going to share a second one. Right? So this actually forms a triple bond. Okay, both nitrogens have one lone pair, but then basically what they do is they share a triple bond. And this one, when it comes to the structural diagram, you're basically going to have 2 ends with a triple bond between them. Our last example is going to be CO2. So for this one, there's my carbon. And my next one, here is my oxygen. The atom that's going to go in the middle is the one with the greatest bonding capacity. So in this case, it's carbon. And by the way, try to bond as many of your atoms as possible to the central atom before you put it on another atom. So I'm going to put those 2 oxygens on my central atom first. I'm not going to try to bond the 2 oxygens together. All right, so there they are. And you can see again that nothing is full right now at the moment. They all are missing electrons to have a full valence. So this oxygen and the carbon are going to share 1 pair of electrons. This oxygen and the carbon are going to share this pair of electrons. And so when it comes time to draw and what you need to hand in, remember, I don't want to see the arrows, is basically this. Okay, so there is my electron dot diagram for carbon dioxide. You've got carbon with 2 double bonds with the oxygens. And again, my structural diagram looks like this. So double and triple bonds are a little bit more complicated, but they still can be solved by using the same rules as before. You're just going to get atoms to share more than 1 pair of electrons, so everything has a full valence. The only thing you've got to be aware of, and do keep track of it because it will help you make sure that you don't make mistakes, is take a look at your atoms at the end and make sure that they have a full valence of electrons. That will let you know that you've drawn them correctly. If we've got an atom with too many or an atom with too few, then the structural diagram that you've drawn is incorrect.